Next definition, definition number 4, it is non-negativity restriction. Now in this definition, what this means, as we have already discussed, the items as we have discussed in the example, table and chair, they should not be in the negative part. Okay, so the non-negativity restrictivity, these are the constants which imply that the variable involved that in linear programming problem are non-negative. Then we are having, next is convex region. Now convex region, what this means? A region is said to be convex region if we choose any 2 points in that particular region and join them. The segment, if is contained if the segment is contained in the shaded region, then it is a complex. Now I can just give you an example for it. Now suppose we are having a region, suppose this is one of the triangle and suppose these are the two figures. Okay, suppose these are the two figures. Now I am just shading this part. Now this whole of the part has been shaded. Similarly, we have shaded this also. Now just go through the statement. Now what it is saying, a region is said to be convex region. A region is said to be convex region if we choose any 2 points in that particular region and join them. Now I am just joining it, A and B in this region and A and B in this region. So 2 points in that particular region and join them. The segment if is contained in the shaded region. Now this is contained in the shaded region and this is not in the shaded because some part of the line is some point of this line segment is outside the shaded part. Okay, so this is a convex region and this is not a convex. Okay, now very important, that is feasible region number 6. Feasible region and feasible solution. To feasible region we are also going with the term that is bounded areas. Okay, so feasible region and feasible solution. Now what this states, the common region determined by all the constants of LPP. No, the common region determined by all the constants of LPP is called a feasible region, and every point in this region is called a feasible solution, and every point in this region is called a feasible solution to LPP. The feasible region is always a complex set. Okay, so now we have gone for non-negative restriction, convex region, and feasible region and feasible solutions.